In case you did not yet notice, we are living in very exciting times. Times where technology really is making a difference in our all-day lives. My name is Hans Hiezakers of Circulation Life Science Consultants, and this is my first video log on the digitalization of the life science industry, or Life Science 4.0. In this first video log, we're going to answer the question, what is Life Science 4.0? Obviously, we borrowed the title from Industry 4.0, so let's first have a look at what was Industry 4.0. So the success of mankind is mainly due to us being responsive to changes. So what are you going to do at this crossroad in history? Are we going to use the new possibilities that are presented to us? Let's look into Life Science 4.0. Let's explain Life Science 4.0 a little bit along the tracks of Industry 1, 2, 3 and 4.0. But as you can see on top of this screen, there's 3 lanes that we should take care of. We are at the junction of these 3 lanes. With the invention in the 20th century of electricity, there came a need of more efficiency and an increase of volume. Goods needed to be affordable for the general public and needed to be mass produced. So we went through a new revolution. We went through organizationally Taylorism, and we established product management to make products affordable for the larger public. This was the second industrial revolution, and the move from the first to the second we named automation. Guess what? People didn't believe this would really change their lives, and these new things were really temporarily and not actually significant. At the end of the 20th century, we went into the third industrial revolution. There was a general marketing need for product differentiation and market segmentation. So smaller markets for more diverse products. Along with that came an increase of rules, GXP rules, but also financial rules, marketing rules, all kinds of rules. And to play in the spectrum of many products, many markets and many rules, we needed computerization. So what drove us from Industry 2.0 to Industry 3.0 was computerization. Now we're moving into Industry 4.0, digitalization. So there is a need for more personalization of products, more personalization of medicines. This needs a new level of adaptiveness, and it is driven by an enormous market pool. Now, there are 3 lanes that end up in the junction of Life Science 4.0. First, we had the industry lane. Second, and probably most important, we have the information sharing lane. Just imagine that even beyond 1800 BC, the first clay tablets containing recipes for medications were found. About 2,500 years later, the first books, handwritten and copied, were provided to a small population of people. Imagine that's a time difference of 2,500 years, and even then, uh, written books were only becoming available to the happy few, the few that learned to read and write, mostly religious people like monks. And approximately 1,000 years later, information became much more available to the larger audience by book printing technology. Books were printed for the larger audience, and knowledge was shared amongst more people, and more people were able to share, consume, and further grow information and knowledge. Still, it was not until the invention of the internet where we were able to share knowledge in a matter of seconds. Rather than going to a library or buy a book, which consumed several hours or days, we were able to share and consume knowledge within a matter of seconds, in any format, and to propel the evolution of science to mesmerizing speed. Now let's focus on the third lane, the lane of socio-demographic changes, ending up into Life Science 4.0. Before we focus on that, let's listen to what Joe Jimenez, former CEO of Novartis and former president of FPA, feels about socio-demographic changes going on at the beginning of the 21st century.
Over the next 10 years, the world will see profound demographic changes. We expect the global population to increase by 1 billion people, with 500 million more people over 50 years of age. Think about that for a minute. Think about what it means for health systems, for societies. Chronic diseases already account for 70% of all illnesses. And as the population ages, that is set to increase. We'll have a larger, older population with growing healthcare needs. Unless health systems adapt to these demographic changes, healthcare spending is forecast to double. These socio-demographic challenges put a growing burden on our healthcare systems, which have responded with an increasing focus on managing costs, limiting treatment options for physicians and their patients. My vision for the FPA presidency is to shift the efforts of healthcare systems from narrowly focusing on decreasing cost to maximizing value. That is, getting the best outcome for patients and all stakeholders from what we spend. I believe this shift has already started, but it needs to be continued and it needs to accelerate.
Let's add some graphics to what Joe just said. The world population has been growing vastly over the past 12,000 years. Look to the left graph on the screen and you can see that at this very moment, more people are alive than ever have died before in the history of humankind. Average life expectancy of humans on Earth was pretty stable for the past 11,500 years. Over the past 200 years, life expectancy has significantly increased. The evolution of medical sciences significantly contributed to that. But this improved health, this increasing life expectancy came with a cost. If you look to the right diagram, you can see the cost increase over the past 30 years. The cost of healthcare doubled between 1918 and the year 2000. That is a period of 20 years. In the next 10 years, from 2000 to 2010, it doubled again. And if we move on like this, healthcare will be unaffordable. It's already becoming unaffordable for some third world countries. And hearing the news channels about the cost of medicines, we need a true game changer to sustain our way of living and quality of life. This is what Adjunction Life Science 4.0 is about. It's about groundbreaking new technologies to improve the quality of healthcare without a linear increase of the cost. There are 4 characteristics of these new technologies. These technologies are more smart, they are more connected, more adaptive, and more virtual. What does that mean? And is it really technology that's going to change the game? Or is it something else? Look to our next chapter on operating models. In all these previous industrial revolutions, and also in Industry 4.0, it was technology that was the enabler, but the real change was done by having a different operating model. What is an operating model? Well, you can see an operating model as a template for our way of working. It can see that the template of the way of working on the left-hand side, which is the pre-industrial era, is very different than the template of working in this Industry 1.0 situation on the right. You can picture these differences as a different way of organizing, different use of physical and human resources, a different working culture, and a different way of information exchange, like in the four-leaf clover. But this is just one way to represent an operating model. The daisy is another way to see the operating model. So we will consistently use this four-leaf clover model throughout our video log, just to make the model understandable. That doesn't mean that in our consulting projects we sometimes use different models. It's all about the acceptance of a model. It's not about how you cut the pie, but about the pie itself. The first element of the operating model is resources. Resources are defined as an organization's tangible resources. This includes human resources and physical resources. The second element is information technology. These are socio-technical systems in which information is captured, stored, processed and transferred to control an operation's past, present and future performance. The third element of the operating model is the organization. An organization is defined by the formalized rules of conduct in processes, along with the governing bodies to ensure these rules are followed. Think about a country. It's about the rules or laws in these countries and about a governing body like the government, the police, and every other governing body to control that these rules are actually followed. Same applies to an organization in an industry. Where an organization often is seen as the hard organization, there's also a kind of a soft organization. We often refer to it as culture. Culture is the behavior of human resources with regards to their interaction and decision taking that is defined by informal rules. Culture is also often referred to as social conformity. It is perceived as very difficult to change, but we will teach you different in this series of Life Science 4.0. The four elements of the operating model kind of apply to all industrial revolutions. They were always in place in Industry 1, 2, 3 and 4.0. But the way they were furnished was different. So what is different to the operating models in Industry 1, 2, 3 and 4 we name the maturity model. This diagram explains in a nutshell what the differences are between the operating models in 1, 2, 3 and 4. On the top side, on the industry side, you can see the Industry 1, 2, 3 and 4. On the vertical side, you can see resources, IT, organization and culture as in the operating model. And as a consequence, in the crossing cells, you can see how the different industries differ from each other compared to the operating model. This video log is too short to explain all 16 different elements here, but we'll discuss 4 of them. The ones that are different in Life Science 4.0. Where in Life Science 1.0, machines and human resources were very task-based. They were able to perform one task completely and provide that to the client. In Industry 2.0, things narrowed down to being single skill. Machine parts and human beings were very much trained or designed to do only one thing. In Industry 3.0, where we had product differentiation, machines and human resources became multi-skill again. Machines became adaptive. You could build them to do other things, and human resources were trained to do multiple things. In Life Science 4.0, resources are becoming smart. Let's have a look what smart means. From a physical resource point of view, smart resources are smart, meaning things have a sensor, a memory, and computing capability, and they can communicate to a network. They are connected, meaning they are connected with digital infrastructure. They are virtual, meaning you don't need a lot of training to understand them. They are basically a digital twin of what the real world looks like. They are analytical. They are able to transform data into information by using infographics that are self-explanatory. And they are adaptive, meaning that they can continuously adapt to the variability needed. How human resources change, we pretty much look at the table from the World Economic Forum of the changes in human resource skills between 2015 and 2020. This shows a trend. It shows a trend in increasing need for creativity and critical thinking, increasing need of emotional intelligence and judgment and decision taking, compared to a higher level of control in the old days. In short, we expect human resources to do what machines cannot do. Be creative. Very important in Life Science 4.0 is the interface between these two, the human-machine interface. This interface is blurring, meaning that the interface between humans and machines becomes very natural. We talk about augmented, virtual, or mixed reality. We talk about infographics, voice artificial intelligence, and chat robots. So we interact with machines as we would interact with other human beings. Information technology changed a lot over these different industrial revolutions. Industry 1.0, we used template only. So we had an example of how to create things and then create many of them. In Industry 2.0, we started with one-dimensional integration, or 1D integration, or often referred to as vertical integration. It is the integration of data into the decision hierarchy to transform data into wisdom. Decisions were taken into hierarchy, hence we needed to aggregate data to take decisions in the vertical column. In Industry 3.0, in addition, came 2D integration, meaning information exchange along the process, or horizontal integration. Industry 4.0 will be about 3D integration, the integration across the value network. This diagram shows you a value network. Basically, all value change between the source market and the deliver market, crossing the make industry. The research process, development pipeline, sales pipeline, supply chain, and financial process. Life Science 4.0 will be about the information exchange between these value chains or across the value network. So information from the financial process to the research process, from the patients to the production process, from the production process to the development process, and vice versa. This will result in a faster product lifecycle. Product lifecycle management, as it is already known in the fast-moving consumer goods world or in the electronics world, will also come to the life science world. We will have more versions of the same product. But obviously, with a holistic control on top of that, we're still producing medicines. Organizations, or how an organization is formatted around processes, also changed from Industry 1.0 to Industry 4.0. In Industry 4.0, we will have virtual teams. Teams being anywhere in the world, executing their competence and adding that to the overall value chain. The move from Industry 2.0 or the blockbuster era into Industry 4.0 is sometimes referred to as an EVO change. EVO standing for Empowered Value-Driven Organization. Empowered meaning with lowered decision hierarchies, value-driven being in the length of the value chain, and organization meaning getting rid of the silos and bring them aligned with the process. These EVO teams do not necessarily reside in one location. They might reside in different virtual locations. This means also that these organizations are controlled very differently. Culture, a hot item in many organizations. Let's have a closer look at that. We explained the model according to Quinn and Cameron out of the University of Michigan. In a 2D matrix between stabilizing and adaptive on the one hand side, and internal and external focused on the other hand side, we have four elements. We have a market element, a hierarchy, a clan, and an adhocracy. So this diagram explains especially clan and adhocracy as it applies to Industry 3.0 and 4.0. The keywords in an adhocracy culture are adaptive, creative, flexible, integrative, and non-permanent. with these characteristics are much more responsive to new ideas than traditional bureaucratic organizations. In this video log, we explain to you that each industrial revolution left an operating model and that all these models are still practical. Organizations do not necessarily become extinct if there is a new operating model. You can upgrade to a new operating model just to become more performant, but you must upgrade to an operating model if the market demands you to do so. If you don't, you might become Dodo 2.0. Note that the life science industry is at the end of the blockbuster era. Small molecules for blockbusters are virtually exhausted and we're moving to large molecules and niche busters. Do you need to upgrade to Industry 4.0 for that? Then upgrade your operating model and let's shape the future of life sciences together. So, did this video log teach you something new? I hope so. It's just an overarching presentation. If you were hoping for gadgets and new technologies, I will show them as well. This is just a framework in where this fits into, but we will in the other video logs talk more about different use cases, case studies, and strategies of the digitalization of life sciences. If you'd like to stay updated, please subscribe to our channel.